we've talked about multiple linear regression and the idea of predicting a continuous outcome from more than one predictor variable. And we saw that when you have a continuous predictor, an X variable, an independent variable, you can just put that in the model. We also saw that if you have a binary predictor, you can just put that into the model too, which sort of begs the question, what if I have a multi-level categorical predictor? Can I just throw that into the model too? Now, the answer is going to be no. We're going to have to do one step first, and that's called dummy variables. We'll need to make our categorical variable into binary because we know we can do that. So let's say we had some data on which hospital our babies were born in. And we have hospital A is coded as 1, hospital B is coded as 2. Athena, are we recording this now?
We are.
What hospital should I choose for hospital A?
How about Tufts?
Oh, yeah. Okay. That's obvious. Okay. So we have Tufts is hospital 1. How about hospital 2?
Children's. Actually, no. Change that to MGH.
MGH. Okay. And then we'll do children's as 3. And let's do, there's another, we'll do St. Elizabeth's, St. E's as 4. All right, so we have our 4 hospitals. Now, if these are coded numerically, you might be tempted just to throw them into the regression model, the numbers, right? And then you might be tempted to run a regression and tell Stata, hey, fit a regression model of this variable. Now, the great thing about Stata is it'll do anything that you tell it to do. And the most dangerous thing about Stata is it'll do anything that you tell it to do. Stata is more than happy to fit a linear model to this 1, 2, 3, 4 that we have here. And the definition of the slope would be for every 1 unit increase in hospital, how much does birth weight change? But there's a couple problems with this. The first problem is that, as you just saw, the order of these hospitals, the coding is pretty arbitrary. Is MGH 2 or 3? Is Children's 2 or 3? We kind of just picked that out on the fly here. The second thing is that if we fit a slope through this, what happens is that the difference between 1 and 2 is forced to be the difference between 2 and 3. And it's the same as the difference between 3 and 4. And the model is fitting some restrictions that might not be true in reality. So when we have these categorical variables with more than 2 levels, you can't put them directly into the regression model. You first have to make them into binary variables through what are called dummy or indicator variables. And the way this works is you or Stata, if you have a variable that has 4 levels, you need to make 3 indicator variables to code that information. Arbitrarily, you'll choose one of these levels as what's called the reference level. So, for example, if you have a variable of dead or alive, it's binary. How many variables do you need to capture a binary variable? Well, just 1. So if you have a variable with 4 levels, how many do you need to capture them? You need to make 3 new variables. I'll show you how this works. Let's say that we had these 4 hospitals. So we had this variable that had these 4 different levels. What we need to do is recode this, generate 3 new variables. So I'm going to choose A, that was Tufts. I'll choose A as my reference. And so if you're a baby born in hospital A, your new data will look like this. You'll have a variable called hospital B, which will be set to 0, C set to 0, and D set to 0. So these are 3 brand new variables, or new columns that are added to the end of the data set. If you're a baby born in hospital B, you get a 1 for the variable hospital B. This is nice because this is how we like to name our binary variables. There's a variable called hospital B. And if that variable is coded to a 1 for you, then yes, you are hospital B. If that's coded to a 0 for you, then you are not hospital B, not hospital B, and not hospital B. So by looking across all 3 of these variables for a given baby, you can tell where that baby was born. Let's say we have a baby who was born in hospital D. Well, we'll look. They have a 0 for this, so that we know, okay, they're not hospital B. They have a 0 for this. Okay, they're not hospital C. And boom, they have a 1 for this. So they're hospital D. So after we do this recode, the data set would look a little bit like this. Here's a baby who was born in hospital A. And in the old data set, or the raw data, there says hospital A. But when I do the recode, there's these 3 new variables, or what we said was G minus 1 variables, and that baby would be 0 all the way across. Down here, we have babies who are born in hospital B, and they get 1s for all of these. So we make these new dummy variables that are binary, and we already know you can take a binary variable and just throw it into the model as long as you're cognizant of what the coding is. So let's make that model that contains gestational age, and now it's got this hospital variable, which has these 4 different levels. We're still going to predict birth length as the dependent variable. So the model will be something like regress length, gestational age, and then those 3 new dummy variables that we made. Regress length, gestational age, and there's our 3 new variables. Now, we still can say, okay, gestational age. On the average, for every 1 unit increase in gestational age, the birth length goes up by 0.79 after controlling for everything else. Now, how do we interpret these other dummy variables? We have to interpret them with respect to the reference level. I told you we chose hospital A, Tufts. We chose that as the reference. There's no variable in here for hospital A, but all the other variables get interpreted relative to hospital A. So we have a slope here for hospital B, 1.73, and our interpretation becomes, on the average, babies born in hospital B are 1.73 bigger than babies born in hospital A after controlling for gestational age, because it's a multiple linear regression. So this is the concept of reference level coding. Take this categorical multi-level variable and turn it into binary variables, which you can fit into the model. Now, why does this work? You don't need to know this. It's kind of cool. Why does this work? Well, remember the definition of a slope. In a multiple regression, we say for every 1 unit increase in X after holding the other variables constant. We'll take a look for a second. Babies born in hospital A are 0, 0, and 0. They're going to be our reference, right? So we have a new variable called hospital B. A baby who's born in hospital B looks like this, 1, 0, and 0. And if you look closely, this new variable, hospital B, relative to babies who are born in A, we see, well, what do you know? A 1 unit increase in hospital B. And what happens here is the same. What happens here is the same. A 1 unit increase in hospital B holding the other variables constant, that's the definition of a slope. And that's why this works. Now, can Statham make the dummy variables for me? The answer is yes. I should have showed you this right away, but I wanted you to see the mechanics of how this works. If you want to make these dummy or these indicator variables, take your categorical predictor and put I dot in front of it. And then Stata will take hospital, make the levels for you, and it'll choose A, or the first one, as the reference. Can you change that reference? Yes. You do this. I, B, which I think is for baseline, and then you pick which level you want to use. So I chose hospital D here, the 4th one, and we see that now hospital D is the reference. What do I choose for my reference level? Well, usually it's pretty obvious. If you're doing physical activity and you're doing none, some, a lot, well, obviously none is the reference. If you work at Tufts, you might always choose Tufts as your reference. If you work for the African American Disparities Network, you might choose African American as your reference. Let's look at some examples of this from the literature. Here's a journal called the Journal of Cancer Survivors, and it's a study on ethnicity predicting system burden in breast cancer survivors. And so we see that they have some binary predictors here. Employment status. Are you employed or not? We've already seen when you have a binary variable, you can just throw it into the model. Here, they're a little bit explicit of what's going on in the background. I'm taking people who are not employed, and it's kind of obvious, but the reference or the comparison would be people who are employed. And we do the same thing here when we do the multi-level categorical variables. Here are data on pain-related system burden in breast cancer survivors. What is the role of race ethnicity? Well, we have a multi-level categorical variable, white, Black, and Hispanic. Here, let's look at this number, 0.778. Well, our definition of a slope would be for a 1 unit increase in Hispanic, how does system burden change? Well, here now the reference is white. So we have to say that Hispanic breast cancer survivors on the average have 0.77 higher pain-related system burden relative to whites. You have to say what that reference is. Now, it's a multiple regression, so there's no period. We have to say, comma, after controlling for employment status and age group. Wait, and there's still no period because there's another comma. If you look in the footnote, it also controls for education, language, income, years, and diagnosis and stage. Now, why are those things not in the table? Those things all have slopes and intercepts and p-values. Well, we don't care about them. They're not the predictors. They're not part of the research question. But in the table, they wanted to show you that Hispanics have 0.77 higher on the average relative to whites after controlling for all of these things. So to recap, you cannot put a categorical variable into a regression model unless you first make binary variables, and this is called dummy or indicator reference level coding.